Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. Today we discuss about regression equation, regression model, or you can say regression line. So first of all, I would like to recall some previous knowledge, that is the linear relationships between two dependent variable, that is interdependence, can be measured by using coefficient of correlation, which is denoted by R. But the linear relationship between a dependent and independent variable can never be measured by using the coefficient of correlation. But why? What was the logic behind that? Because such sort of relationship can be feasible, can be measurable by using an equation. Simply, when we have some input, that is independent variable, and an output, that is dependent variable, or when a dependent variable is linked with an independent variable to observe the relationship, so an equation or a model is only be a choice here. So we can say that an equation or a model must be used here to serve the purpose. Without using model, without using an equation, we cannot proceed further in such case. So I do expect that you have got the main point, that why we use an equation, why we use a model. In fact, the analysis of linear relationships between two variables, between two quantitative variables, leads to an equation, leads to a model that can be used to predict, to estimate, to forecast the values of dependent variable, that is output, by using the values of associated independent variable, that is input. So we can say that the formulation of an equation, the formulation of a model, is heavily based on the analysis of correlation. And if such relationship can be expressed, can be highlighted mathematically, it enables to use it for the purpose of making predictions, forecasting, because we know that the reliability, the stability, the consistency of any prediction depends on the strength of the relationships between variables. That is, if there is strong relationships between the variables, predictions will be most reliable, and if there is weak relationships between the variables, in such case prediction will be less reliable. It is an important point to be noted down that one of the major difference between regression and correlation is that in regression the relationships between the variable is functional. In simple words, we can say that any relationships that can be observed, judged, or inspected by using an equation or model is declared as functional. While in correlation, such drama doesn't happen because both the variables are dependents, and hence the relationship is not functional, that is purely random. So let's come to the point that if the relationship between variable is okay, then the mathematical expression given by straight line is actually called regression equation, regression line, or regression model. Population regression line is denoted by capital Y is equal to alpha plus beta x plus epsilon, while sample regression line is denoted by small y is equal to a plus b times x plus epsilon. Actually, we have two regression line, that is y on x and the second is x on y. Y on x means y depends on x, y is a dependent variable and x is independent variable, while x on y shows that x depends on y. Here x is dependent and y is considered to be independent variable. But it is an important point to be noted down that y on x is a general regression line, because most of the times y variable is considered as dependent variables and shown in the left hand side of an equation or left hand side of the model. So the basic difference between the two regression line is only the directions of dependency. That is, the regression line shows the directions of dependency in y on x. Y depends on x, while x on y mean x depends on y. So in regression, dependence of a variable is represented through straight line. Otherwise, regression is said to be non-linear, curvilinear, which is not our mission. So along with it, regression line gives the best estimate, the superior estimate for y for any specified value of x. But here's the question mark, that y is the best. What is the reason behind that it is considered to the best one here? Because of that, such equations are derived by using the method of least square, also called OLS. OLS stands for ordinary least square method. The sum of the square difference between the observed and estimated value must be least, must be minimum, as small as possible, which is a principle or criteria of least square. Or any simple words, we can say that of all the possible equations that we might find the least square procedure, choose the best equation for which the sum of square of error is minimum or small. That's why we prefer this method, least square, and the regression line obtained by the principle of least square is considered to be the best one. I do expect that you have got the point that what is regression, what is regression equations. So inshallah we'll meet with the next video. Assalamu alaikum.